these new standards. When I got to hear and to meet David Foster, one of the things I'm learning is that many of you already know him. He is, I'm going to introduce him now, and I can, I have a little bio, but he's also working with Oakland, who's also contacted us because Oakland is also trying to re-enter the county in many ways. They want to be in line with what's going on countywide, regionally, and throughout the state. And I think that's a goal for all of us right now. So it's a big opportunity. It's a big opportunity for us here at the county office. And David has been playing this really important role through the Silicon Valley Mathematics Initiative. How many people know David Foster? Heard him. So you know that he runs a nonprofit through San Jose State. He is affiliated and consults with Berkeley, Stanford University, as well as San Jose State. And he is a consultant to the Smarter Balance work that's going on. Alan Schoenfeld, who's one of the co-authors, is right here at the University at Cal. So it's a really important opportunity for Alameda County and the districts that you all represent to come together and to start playing a lead in looking at how we can put into effect these new standards. And David is here. I'm not going to speak any longer. He's going to speak. I also wanted to introduce Gretchen Muller, who has a history of working with David, who and in a number of districts organized the Asilomar conference that just took place on math, and has now joined us as a lead and will be working with all of you. So with that, David, you're on. Is David mic? Are you mic? Yes.
No, I can take this off. I'm on, right? Okay. It's great to be here. I feel really fortunate to have the opportunity to talk to you all about what's happening with the Common Core standards in mathematics, what's happening in with Smarter Balance. I can actually even talk to you a little bit about what's happening in Park. Since the passage of the Common Core standards, and I'll go through and give some history, there's been, we've been consulting with some of the Race to the Top states. I just came back from New York, and I've worked with North Carolina and Georgia and a number of other of the states that are Race to the Top. And I can bring back and sort of share with you what people who've got a lot of money to implement monies for Race to the Top, what they're doing. Some of it's smart, some of it's not as smart as I hope. But anyway, I'm here to talk to you really about what's really happening with the new assessments. And I have some examples that I want to share with you that we have designed for Smarter Balance. We designed it for Park. They've actually, both of the two organizations have contacted us because the work that we have been doing in this Bay Area for a while around assessment is now in vogue. I sometimes say I feel like a pair of old bell bottoms. You know, if you hang around long enough, you come back in style. So anyway, let me just talk. This is, anybody know who this is? Some of you guys know who this is. This is Bob Noyce. Bob Noyce, nowadays I used to do this talk about Hewlett and Packard and jobs and stuff, and now I say Mark Zuckerberg, and I just say, anybody know who Mark Zuckerberg is? They all know Mark Zuckerberg. Nobody knows Bob Noyce. I say Mark Zuckerberg would be poor if it wasn't for Bob Noyce. Bob Noyce actually invented the silicon chip and started Intel and a number of other companies. But the reason why I have him up here is for two reasons. First of all, this idea of optimism. You know, I'm very optimistic, even though our financial picture still doesn't look very bright. But the opportunities to think about how we can support changes in teaching and learning, I think, are very, very bright. Bob Noyce passed away at a rather young age in 1990, and his family set up a foundation. With that foundation money, they did work. The foundation did work in early literacy and in mathematics. And from that work, which is sort of R&D work, nonprofit R&D work, a lot of the innovations for new assessments were developed and are used. And that's where a lot of our work is. The Silicon Valley Math Initiative works with 60 member districts and schools, mostly in Northern California, but also in New York City and abound. But what I'm going to talk about right now is sort of the state of mathematics in America. And if you've been around education at all for any time, you know, you feel these pendulum swings sort of going back and forth. And we are in a huge pendulum swing right now. And it's really tough because we're going to have a foot in one camp and needing to move to the other camp. And how do we do this transition between these between these two movements? But I'm just going to go just a little bit back in time to No Child Left Behind and talk about that a decade ago. The innovation was No Child Left Behind. What do we do? No laughing, no laughing. So just at that time, all right, you don't know where you don't know you don't know where my politics lie here. Okay, so the goal of No Child Left Behind was to close the achievement gap, and the theory of action was that every state needed to come up with a set of standards. Then they were supposed to come up with an assessment test that would measure and report achievement for every single student, and then schools and districts will be held accountable with sanctions if, in fact, we didn't close the achievement gap for the various groups. We all know that. We lived that. We're all part of that. And so I just want to talk about, so how did that go? So here is, we don't have a national test, but the closest thing we do have to a national test is the NAEP. And the NAEP is, we're probably all familiar with. It comes out every 2 years. I haven't got around to making a new chart like this, but it doesn't look that much different from the 2009 data. And so we have these scores, which show you the average of all students, how U.S. students scored in mathematics at grades 4, and how, again, they scored in 8th grade, and then these demographic breakdowns of how students performed. And those look just like numbers until I tell you that 10 scale points is 1 grade level. And then it gets pretty scary. If we look at English language learners in 8th grade, they are performing about the same as all students in 4th grade and 4 years behind their counterparts overall. And you see vast gaps. And so, in fact, the achievement gap hasn't closed, and actually it's gotten larger. Of course, this is across all America. We're not talking about individuals. Lots of us have made some gains around these lines, but in general, the gap has gotten wider, not smaller. And we have many schools going into program improvement. And it's not just that you go into program improvement, it's sort of purgatory. You never get out of program improvement and the problem. So nobody actually defends the status quo, but also we have a Congress that's pretty frozen and can't get around to doing anything about it. The other thing that we have to know, besides those demographic categories that I looked at, there are vast differences in how different states score. Lots of times we hear about the international comparison tests, you know, the TIMSS, PISA, these national comparison tests, and we hear about Singapore and Hong Kong and Finland and Japan and all those, and how they are significant, how the U.S. is significantly underperforming those. But that's not the whole picture. If you break us down and compare by states, well, if you live in Massachusetts, you actually perform better than Japan. But if you live in California, you outperform Mississippi. That's it. We're 49. And a lot of that has to do with our state test and how we're preparing kids. When you look across the different states and you start to examine the different state tests, they are the amount of money a state invests in their state test and what they ask kids to know and be able to do are radically different. And unfortunately, California invested into a very inexpensive test that can be machine scored, and it's all multiple choice. And unfortunately, since it's the coin of the realm, I think that a lot of the higher level thinking skills are not being measured here in the state. So, a little less than 2 years ago, the Common Core standards were written in English language arts and mathematics. I have the picture of Obama and Duncan and Biden up here, but those guys really weren't responsible for the Common Core standards. They encouraged it, but they weren't responsible. Actually, it was commissioned by the National Governors Association and the state schools officers because education is a states' rights issue. It's not a federal issue, although these guys were very much behind it. But the standards did come out. And so I'm going to just describe a couple of things about the standards. So when you look at the current No Child Left Behind set of 50 standards, you see differences and similarities. Some of the differences that you see is how early topics got introduced. But what you don't see, like every single one of the 50 states, we teach multiplication. We teach fractions. We teach the quadratic equation. We teach, those are sort of the nouns of mathematics. What happened about 10 years ago when we developed standards in our, or even before that, we developed state standards. It was more about sort of an argument about which standard we want to put at which grade. So when are we going to actually introduce fractions? When are we going to actually teach algebra? When are we going to, and in California, we were labeled world class because we had kids teach everything about 2 years earlier. And in a state like Texas, they taught almost everything 2 years later than us. Of course, if you go back to this map, they're green. They outperform us, even though we were encouraging that everything get taught earlier. So the nice thing about the new Common Core standards is, even though the nouns are the same, we still teach multiplication, we still teach fractions. What the Common Core standards brought us that we've never saw before in any of those state standards were the verbs of mathematics. We know the nouns, but the verbs, how you actually do and think and act. And that is so important and has to be emphasized in the work we're doing. So I just want to take just a little bit of a moment to highlight what this is. So first and foremost, in these state standards is this idea of solve problems and have kids persevere. So these aren't exercises. These are problems. These are non-routine problems, really things that you need to act and be able to do. So problem solving, first and foremost, is a huge shift and a huge emphasis about what's happening. Number two, it says reason abstractly and quantitatively. When I ask teachers what they think they do better, abstractly or quantitatively, they say, oh yeah, abstractly is really hard. We don't do that very well. Actually, when you look at international comparisons, when we look at algebra and algebraic thinking, we hold up pretty well to other countries. But when you think about measurement and geometry and things, we are at the very bottom. Kids don't measure anymore. So this idea about quantitatively is not just knowing 37, it's 37 what? 37 people, 37 gallons, 37 inches, 37 miles per hour. What is it about? And how big is it? How does it compare in size? How do we use it on the number line? And these kinds of things when the Common Core standards were commissioned. They were asked to be internationally benchmarked, and to prepare kids to be college and career ready, and to be fewer, clearer, and higher. Well, this whole idea about internationally benchmarked, around the world, the number line and quantitative thinking is held at a premium. And I think that's one of the reasons why our kids don't have as great a number sense. So that's number 2. Number 3, construct viable arguments and critique the reasoning of others. This isn't what teachers should be doing in their classroom. They've been constructing arguments all along. It's what the kids need to do. So we have to shift that to what kids need to do. Number 4 says model with mathematics. Model with mathematics isn't the model, the verb model here isn't about demonstrate. It's not necessarily using manipulative. Model is a sort of a technical word mathematicians use to take a real life situation and mathematize it. Put a mathematical structure on it so you can solve the problem and attack it and be able to do. So getting kids to, well, we hear all the time kids in class say, if you just set it up for me, I can do the math. Well, the setting up is the math. The other thing is just mere calculation. So getting kids to be able to do that. And I will go through and give you examples of other these, but these verbs are at the heart and soul of doing mathematics. And this is a huge paradigm shift to what's happening in many of our classrooms. The other thing about the Common Core standards that are new or different in mathematics than it was before is, in the past, they sort of talked about when you went state to state, says, how early are we going to introduce multiplication, or when are we going to introduce fractions, which became detrimental in some cases, and it was the wrong way to think about it. Because an idea like fractions is a really important idea. And so first of all, we have to, what is it mathematically? What is the mathematical structure that makes fractions important, and how it builds on the future? And also, developmentally, when can students really understand that? So basically, what the writers of the Common Core, and there were 3 main writers who commissioned a lot of other people to actually contribute, they actually assigned experts to write learning progressions about the idea of how's fractions built over time, how's multiplication built over time, how's algebraic thinking built over time, how's proportional reasoning, these really fundamental, big, important ideas in mathematics. So these were designed around progression. So the way that fractions is asked to be taught is completely different than what we've traditionally done. So what have we traditionally done with fractions? We usually take some kind of round food and divide it up, and that's how we learn fractions. But the thing is 1/3 is a number. It's no different in terms of a number than 5 is. Where is 1/3 on the on the number line? What's its quantity? How big is it? And how do we make sense of that? And how do we learn what 2/3 is if we know what 1/3 is? And these kinds of ideas. So the way that it's rolled out, starting in 3rd grade and working all the way up through middle school, is a really nice piece of, curricular thinking, I guess, is the best way to do it. But these progressions are really, really important. And then at the high school, well, traditionally, and I think this question has been asked all the time, why do we say to students, I want you to learn algebra. Stop. Now let's learn geometry. Stop. Let's go back to algebra. Oh, you don't know any algebra. Yeah. So this traditional sequence that we've lived with forever, the Common Core Standards allows high schools to continue to do this, but they also allow kids to learn mathematics in a more integrated way. The way that mathematics was learned throughout mankind. We didn't just learn, we never learned algebra independent of learning geometry or data and stuff. So there is this idea that we could have an integrated sequence. One of the jobs that I'm doing right now is that Phil Darrow that many of you might know, was one of the 3 chief writers of the Common Core Standards in Mathematics. He just got a significant, well, a year ago, we got a significant grant from the Gates Foundation to design a new K-12 curriculum, and this is even before Apple's announcement a week or 2 ago, that will all be delivered on a tablet. And we are designing this K-12 curriculum to be consistent with these Common Core standards. And it's through Gates. It's a nonprofit. It's not like a for-profit idea. But we wanted to get a product out there and a map of those. Well, it's very interesting. I'm actually heading up the high school part. And we have created an opportunity where you could go through one or through the other. Now, we're just in the early stages of development of it, but it's pretty exciting work. So this is something, the reason why I talk about this is an opportunity for high schools to have conversations about what it is we really want kids to know and be able to do, and give some flexibility to how the curriculum might be designed and looked at. And I'll talk about how this matches up with, but what about these assessments? And I will talk about that in a minute. So there's 2 possible ways that districts, that school districts, states could go, depending on who decides what. So I think this map is pretty much up to date. 46 states, Washington, D.C., and the U.S. Virgin Islands have adopted the Common Core standards. Montana is a different color up there. They've actually adopted it. Now it should be green. Minnesota should be a different color because Minnesota has said absolutely yes to English language arts and is still thinking that their math standards are superior. So they're sort of on the fence. Then we have Nebraska and Virginia. I don't know their story. And then we have Alaska and Texas. But those guys think they're different countries anyway, so who knows? No, but anyway, so these really are default national standards. As soon as the feds assign title money to it, we'll see that whole the whole map green. But anyway, so they are, it has definitely moved forward. So what did the feds do? Well, the feds put out a RFP for, and gave Race to the Top money for the development of 2 different organizations to create the next generation tests that will measure English language arts and mathematics. And so the one is the PARC states, and it's being managed, fiscally managed by Achieve. And the other is Smarter Balance, and it's going to be fiscally managed, or is being managed by West Ed. That doesn't mean those are the guys that are making the decisions. They're just, they're part of the organizing group. And as most of you know, when we first adopted the Common Core standards and Governor Schwarzenegger was involved, we picked, because we had to pick one or the other, we picked PARC. And then this last summer, under the Brown administration, we switched and we went to Smarter Balance. I am working with both. They both have very smart people, and I'm really pleased that we are now with Smarter Balance, because of the 2, I think it's a better test. But both of them have good people working for them. What's that? They have a better name, of course. There you go. All right. And you can see that Smarter Balance has 31 states, and the PARC has 23 states. And every time I say that, somebody raises their hand and says, well, that's more than 50. You're right, because there's a few states that are in both. The technical term for that is promiscuous states. Not my term, their term. But there's a couple of states like Ohio who is waiting to see how it all plays out, and then is going to finally pick. When I talked to Michael Lack, who is the head of mathematics for Arnie Duncan, and I really pressed him on, why 2? Don't we need just one test? He said, well, you know, Americans don't have, officially, on paper, we don't have monopolies. So it's the American way to have two, at least, I guess. But eventually, these tests will have to be equated in some kind of way to do some comparisons. So let's get into talking about the tests and what they look like, right? So this first idea is when you're in the testing community, there are basically two huge factors or two things that developing tests companies or organizations need to be worried about. One is reliability, and the other is validity. Here in the United States, we obsess with reliability. Reliability is the ability that we have this sort of this fairness idea that if we give the test to the student on day one and no treatment is done that day, and we give the same test to that same student on Tuesday, that the score would be the same. And so if we have those psychrometric guarantees, we feel that it's a really legitimate test. On the other hand, there's validity. Validity we're not so concerned about, but in the United States. So that's my opinion. Validity, does this actually measure what you value? So my biggest correlation is, we could measure people's age by their height. It would work fine for a while, and then after a while, who cares? They're old anyway. But but this idea that we use these surrogates and we feel that really measures what we concern is a concern that that a lot of us in the testing community is worried about. And when we look across international tests, we are more concerned with the validity measures. They're more concerned with the validity measures than ours. But with that said, let's go forward. So there's the PARC states. This is who we used to be part of. You can see they're mostly on the East Coast, and there's some of the more larger states like New York, Pennsylvania, Illinois, Florida, and the like. And then there are the smarter balanced states. We're more in the West, and there's more states here involved. But I'm going to specifically talk about what I know about the state of smarter balance, and you guys get briefed quite a bit. And as you know, it's a moving target. So I'm going to tell you what the best information is today, and a week from now you could call me a complete liar because it could change. But let me give you what I know up to date. So currently, you know this better than I, the STAR test is assessed in grades 2 through 11 and writing at 4th and 7th grade. It's only done with paper and pencil options. It's given around the 85% of the way through the year. It's only multiple choice, and it's part of the AYD and our state's API accountability systems. How that's different with the Common Core? Well, we're going to give tests. We're going to wait until 3rd grade to give the first test, 3rd through 8th, and one time in high school at 11th grade. It's not that there might not be end-of-course tests that come out, but it's not going to be an official test that's done before. This will really allow kids to go through an integrated system versus, in PARC, they're going to have a little bit more trouble because they guaranteed every single year. But since Smarter Balance has said just in the 11th grade, what they really assured is that you could do both a traditional sequence or an integrated sequence. The key word here, a lot of things that when I go and talk to groups like this, the big thing out there that people seem to really understand is that this is going to require all these computers because the test will actually be delivered, and I want to say the word delivered by computer. You know, a lot of the reason, a lot of the motivation, political motivation for moving to this sort of national test is the economy of scale. And so with the economy of scale, instead of having 50 different people designing tests and all the like, we have one set, or two sets in this case, and this whole idea. So this delivery is very important. And I think it's really an important distinction to make, because it will be different in mathematics than it will be in language arts. In language arts, the keyboard is a natural medium for communicating in language. The keyboard isn't nearly as friendly when you start to do it, try to work out mathematical problems. So, and the last thing we need to do is to create some interface that we spend 2 or 3 months out of a school year teaching the kids to use an interface so that they can answer that. What a waste of time that would be. So there is a lot of lobbying done to make sure that kids are able to actually work out their math problems like where they would normally work out. So even though it's delivered, it's not necessarily answered or machine scored. There will be some, but it won't be all by any means, and I'll break that out in a minute. It's going to be taken during the final 12 weeks of the school year, and I have, I think, a little bit more information about that idea. The performance tests, there will be performance tests and comprehensive end-of-the-year computer-adapted assessments. That's the two things that are going to make up this test. And until we have a new authorization of No Child Left Behind, we don't know what the accountability system will be. And because it's election year, the likelihood of seeing anything between now and a year from now is probably unlikely, unfortunately. So here is their scenario. They're going to have computer-adapted assessments and interim assessments. So these here are like practice tests and interim assessments and maybe some formative assessment information. These are what was promised in the Race to the Top application, that not only were they going to be able to design a final test at the end of the year, but that they would have materials to help students understand and teachers understand what will be on the test. But it's these two parts that is where the test is going to be given. And even though they weren't willing to draw a line straight up here and straight up here for this graph, this is really what they're thinking. So what they're thinking is somewhere so 12 weeks from the school year is March, 1st of April, in there. This part of the test will be given. And about somewhere in May, this part of the test will be given. And those two parts of the test will be put together to make up the score. And I'm going to give you a little bit more of the current thinking, which all could change. So I want to tell you what's most likely to happen, and with the caveat is nothing's in stone, right? And we have 31 states that are going to argue over this. Yeah, well, we are. For good or for bad. Okay, so that's sort of the design of the test. Let's get more specific. So, how many people are familiar with this model of claims, evidence, warrants? Okay, I didn't know much of it until I got involved in this work with both of these two organizations, but the way that they are making their designs for analyzing arguments is this idea of using this argumentation model called claims, evidence, and warrants. So what's a claim? A claim can be a big statement, which I'll show you some, and some smaller statements, which I'll show you some. But it's a statement about what we want kids to know and be able to do. So a statement, what kids know and be able to do. The evidence The evidence are the characteristics of what students' responses or work would look like. So what are the characteristics they would look like? And these are tied, when we had to create task models to design these new tests, we had to actually come up with these claim statements or subclaim statements and these evidence which had to cite the actual content or standards of mathematical practice from the Common Core. So the evidence actually comes from the actual standards themselves. And the warrants, well, the warrants are the assessments themselves. So what actually is the item, the assessment item that a kid know and able to do? So I'm going to now reveal behind the curtain this work. But and I'm going to only focus on smarter balance because I'm here in beautiful Hayward. So this actually came out, and they revised it a little. It first came out in August of this last year, and this is the content specifications for smarter balance in mathematics. So this is a document that tells us what they are able to do. You might recognize a few people who were authors on this. One is Linda Darling-Hammond from Stanford, which we did a lot of pilot work for. In fact, I'll share with you, we did, for 2 years, we did pilot work and designed the assessments that she had us commissioned to do in Ohio. And then there are this is a gentleman named Hugh Burkhardt, Shell Center, Nottingham, England, and Alan Schoenfeld, University of California at Berkeley. If you know these names, it's because you've done the Mars test. So these are actually the lead authors were the designers of the Mars Balanced Assessment Test. So it won't be surprising what it'll look like. They came up with four major claims for what this assessment is going to do. Claim one, students can, and I'm reading it to you so you can see it in the back, and I really want to emphasize, students can explain and apply mathematical concepts and carry out mathematical procedures with precision and fluency. Something that we would all want all kids to be able to do. Claim number two, students can frame and solve a range of complex problems in pure and applied mathematics. Claim three, students can clearly and precisely construct viable arguments to support their own reasoning and to critique the reasoning of others. And claim number four, students can analyze complex real-world scenarios and can use mathematical models to interpret and solve problems. So these are very high level, especially the claim 2, 3, and 4 are very high level, high cognitive demand kinds of things to be able to demonstrate. They basically put the kinds of tasks kids will be doing into three buckets. Novice, and these were their terms. So novice, those are short items focused on skills and routines. We're very familiar with those. Those look like multiple choice problems or fill in the blank, something that can be machine scored. Let me jump down to expert task. An expert task is a rich task. And realistically, if we had all the time in the world and all the resources in the world, quite honestly, this is how we would want to assess kids. We'd give them a good problem. We'd be able to watch them, look at them, read their response, maybe do an oral interview with them, but we would let them, without scaffolding and all this other stuff, allow kids to do this. Then we would really feel pretty confident kids could solve real problems in the real world. That would be the purpose of this. But in a high-stakes testing environment where we're going to test every kid in the country, we don't have that. So what are the challenges? It takes a lot of time. There's also this threshold. So you will get, if you give tasks like this, you will have this bimodal distribution where there will be some kids that got it and could do really well on it, and then you'd have a lot of kids that could probably do nothing on it. At least it seems to do nothing on it at the very beginning. So those are problematic because that doesn't really help us really see what kids know and are able to do, and it's expensive. The other thing is that even a rich problem like this, it will explore those mathematical practices probably pretty well, but what it won't do is cover a lot of the curriculum. When you have a real big problem, the mathematics is focused on one area, and so if part of your job with an assessment is to cover the range of standards, this will take a lot of time and cover not enough standards for the time. So there has to be something in between, and the something in between is what we call an apprentice task. And that is still a performance task where we want kids to work and show their thinking, but it's designed in such a way that there's access into the problem so all kids can get started on it, and then they would be at the core and be able to do. I'll go back and be able to give you exact answers. So let's go through these models: novice, apprentice, and expert. So novice, we don't need to do too much with. Novice this is a multiple choice, changing an expression in scientific notation and completing it. Here, part 2 is a short answer where you have to figure out a set of values for x and y that would make this statement true. Both of these can be machine scored. Both of these are quick items. There's also a little bit more sophisticated items that you could use with a multiple choice test, and this was an example. All these examples come out of, these aren't the ones that I make up. These are the ones that actually came out of the content specification, but for Smarter Balance. But right here is this water tank, okay? And so I'm going to have you try to reason through this for just a little bit. So this water tank has this shape where there's this cone down below and this cylinder up above. And what happens with this tank is empty to begin with, but I start filling it with water from the very top, and the water goes in at a constant rate. As it goes in, the height of the water as it fills up will rise, right? So these graphs depict how the speed or the rate at which the water rises in respect to time. So my question to you is, which of these 5 possible graphs would best represent how that water rises? So I'm going to let you think about it, and you can turn to a partner, and you guys can work collaboratively. No, I don't think I know. Let them do math, and it just goes. The whole talk goes to chaos. No, it's good. Who'd be willing to share their thinking on why they picked one graph or the other? Yeah. Okay. And at what point would it gradually level off into the cylinder? Yeah, okay. Did somebody have a different argument? Wait, they said B. They say B because with the cone it's going to rise really fast, and then once it reaches the cylinder portion, then it's going to be constant, but it's still going over time, right? Because let's talk about E, because some people think it's E, and so when we have this horizontal line, it's saying it's not getting any higher, it's just over time. Some people argue, well, it's spilling out over the top, and that could be, but think about that this has to rise at a steady rate at some point, and this never seems to rise at a steady rate. And it has to rise at a steady rate for actually a longer period of time because it's going to go up fast. So, what do you think this question would be? You know, this whole idea of getting kids to understand this notion of function and graph is a really important idea. I mean, this is really the underpinnings of calculus. There's a lot of stuff we do in algebra that you never do in calculus. But this stuff is actually stuff that would prepare you to do well in calculus, but it's quite accessible to really understand the phenomena. So there will be graphs around this line. I don't know if this item will be in that, but this whole idea about being able to interpret these continuous graphs, not bar graphs, but these continuous graphs is a big idea that probably kids in 5th grade could do, definitely at middle school, and by high school we would want kids to be very skilled at this. Okay, so I've sort of exhausted this idea of so it's not all so there'll be a good portion of tasks that will involve multiple choice or short answer. But there'll also be these apprentice tasks. So these apprentice tasks are designed in a way where you actually ask the first couple of questions might actually be below grade level. But it would get kids into the problem, and you could see kids could be awarded some points, so they're not getting a complete zero. You know, when we give an item to a kid and we give them a 0 score, that's not very helpful. I mean, it tells us that they didn't know this, but did they not know it because they misinterpreted the question? Did they not know it because and if they even got it right, did they just guess correctly? So we want to know what kids know and are able to do so we can move learning forward. So the first part would be actually below grade level. Then at some point, pretty rapidly, you want to get into what's standard. But just because kids can answer a question at standard, do they really understand it? Do they have a conceptual understanding to really apply it? Do they have the conceptual understanding to be able to generalize it and thus so? So this idea of having a task with this structure of a ramp is important, and that's what we call, or they called an apprentice task. Sometimes it's called a scaffolded task. So this is an example of a scaffolded task. It comes out of their content specifications. It also came out of our last Mars test, coincidentally. But anyway, this is one that involves algebraic thinking, and it talks about Bill's going to order new jerseys for his baseball team. The team's got the logo on it. Bill has asked 2 companies. The first company, called Print It, will charge $21.50 for each jersey. So they need to write an expression for n number, an equation for n number of jerseys to calculate the cost. So we're looking for the cost is equal to $21.50 times n. And that's what we would ask. And this would be the entry-level question. And then the second question says that Top Print has a one-time setup fee of $70 and then charges $18 for each additional jersey. So once again, we'd like an equation here. This equation, if it was correctly written, would be C was equal to 18 times n plus the $70 setup fee. And then we get into the heart of what this was, because this is probably about an 8th grade item. Bill decides to order 30 jerseys from Top Print. How much more would the jerseys cost if he bought it from Print It? Show your calculation. Finally, the last, up the ramp, seeing if they really understand it, use 2 equations for 1 and 2 to figure out how many jerseys Bill would need to buy for the price of Top Print to be less than the price of Print It. Explain how you figured it out. So this is an example of a task along those lines. This will be done on a computer. Now, for those, so what I usually get, this will be delivered on computer. This will have to be hand scored. Well, it's going to be, so it could be, all this hasn't been worked out yet. So just because it's, well, so here's a couple of scenarios. the one scenario would be that it was delivered on computer, and then the kids would have a place to put their answers, but also have to actually have some way of scribing what they did. You can't solve this problem without scribing, and this can't be machine scored. It has to be scored. It would have to be human scored. And so one of two things can happen. It can either be delivered to us, and then we would print a PDF of it, and kids would write it like they normally do, and then maybe it needed to be scanned back in. All these things could happen, or there would have to be some kind of interface that kids would have to be able to do it. And all that stuff still hasn't been worked out about how it's going to be delivered back. But let me just talk about this idea of having it machine scored. And I hear all the time about how are they going to afford to do this? How can we do this? As the Silicon Valley Math Initiative, and many of you of the districts in this have participated in this, each year we give a test with 5 of these items to students in grades 2 through 11th grade. We give it in March. Kids do 3 of those, like that baseball jersey thing, 3 of those on one day and 2 of them on the next day. Then there is a rubric that goes with every specific task, not a generalized rubric, but a specific task. And districts come to a central training place, and we train the teachers at that grade level, or elite scorers at that grade level, to actually score this work with benchmark papers to standardize their performance. Then they go back to their districts, and these get scored. Sometimes it's on Saturdays, sometimes it's after school, sometimes years ago when there was sponsored time during the school day, we scored it there. We randomly pull from every single district, we randomly pull a 5% sample of tests that we rescore with math and computer science students at San Jose State. We send that data to an independent data company called EDS, and they create reports for us. One of them is that they confirm whether or not the tests were scored reliably or not, and we get an inner score reliability of over 95%. So this idea that things can't be on a grand scale come up and is just not true. And we've done it from anywhere up to 80,000 student papers, and we do it every year. And so what I wanted to share with you is just a little bit of data from it, just to share with you what you learn with a performance assessment that you might not learn with a CST. So this is a chart from last September for 45 districts in the greater Northern California. And these are our 5 performance levels from the CST test. These are 4 levels for the Mars test. So a Mars 1 would be minimal success. Mars 2 would still be below standard. Mars 3 would be meeting minimal standard. And Mars 4 would be high up on that ramp consistently. And so when you look at these numbers, all the ones in red are the percentage of kids that were below standard on both of the 2 tests. And when I add these red numbers together, I get this 13.7 down here. So this table right here is collapsed down here. And then when I look at the lime green numbers, those are the percentage of students who met standard on both tests. And when I add those up, I get 72. When I add these 2 numbers together, I get close to 85%. So that means that teachers at the 1st of April have a set of actual tests with scores on it that predict 85% of the time what's going to happen on the CST test, at least in terms of these broad categories. But those aren't the reason why I'm showing that data. What I'm showing is these 2 numbers is important to me. These are where you do well on one test but not well on the other. Who are these kids, and what does this tell us? Well, here at 2nd grade, and 2nd grade's sort of unique. It's the only test, it's the only grade level that we read the test to the kids, and it's only done 1 task per day. All the other ones are the student has to basically read it themselves, and they have to do it in 2 days, 5 tasks. But anyway, let's start with the blue. Those are the percentage of kids who met standard on this rich performance test, but did not meet standard on the state. When we each year we look at who makes up this number, and what we find as a general categorization of those are challenged readers or English language learners who, if you interview the kids or you ask the teachers about them, they seem to know the mathematics. They just have trouble negotiating the state test and getting through a question in 35 seconds or whatever it is. Versus this number Alan Schoenfeld calls the false positive. This is where a parent receives, oh, my kids met standard on the state test, but when you actually give them a problem that there isn't multiple choices and something to pick on, where they have to explain their reasoning and how they do it, show their work, they're not able to do it. Well, at second grade, these two numbers are pretty close together. But by third grade, we see differences. This number now has jumped to 12.7%, and this has gotten smaller. In fourth grade, fifth grade, look by sixth grade. By sixth grade, it's over 20% that are not able to actually explain and do the mathematics. This number is dwindling. Let's go on up in the grades. What happens in middle school? This number almost disappears by seventh grade. Now we're up to 40%. These two grades are really hard to think about and to look at because it's tracked, with the algebra question and who, but you can see some vast discrepancies. But this last chart, which I'll blow up for you, this one, this isn't all geometry students. This I put in here are just the students who are in 8th grade who are taking geometry. How many 8th graders in geometry? Are they, do we have any hope for those kids? Do they have a future in STEM? If they don't, we don't have them, right? Look at this. Almost 85% of the kids met standard on the CST. 36% of them can't do a proof. These are our best and our brightest. Many of us don't have these classes. These classes come from the richest communities in America whose parents are venture capitalists and research engineers. We're talking about Woodside, Portola Valley, Saratoga, Los Gatos, Cupertino, Palo Alto. That's what these kids, those are the ones that make up the majority of these numbers. We just haven't been given the whole picture the whole time. So anyway, I worry as we switch to smarter balance what's going to happen. The other thing that I want to share with you, and I'm going to try to do this really quickly because I know that we want to get on to other parts of the agenda and things, but the last thing I want to talk about is this expert problem. What's these big problems? Well, Linda Darlene's Hammond's group came to us about two or 3 years ago and said, we want to do a big, rich problem in mathematics for kids who are graduating from high school or in high school. And we're going to pick the end of the 11th grade year, and we want these rich problems for kids to be able to design us some tasks and score it for us. So what happened is we came up with a bunch of them. This is an example of one. So, and we wanted it in real life. So here's sort of the scenario. We're in Ohio, right? We're in a cold climate, and the heating costs are eating us up. So in the summer, we get our house, we get insulation installed in our house. This new insulation. And we put out quite a bit of money to be able to do this. So we expect that we're going to save money when the winter time comes. So the bill comes to us in January, and I look at my bill, and I think, wow, that isn't much savings. Did I get ripped off? So I go to my records, and I pull out the bill from last year in January. And I'm looking at it, I says, how do I compare these two? Because, look, the rates have gone up, and it's colder this year. How do I make sense of it? How do I know whether or not I am saving money, losing money, it was a good investment or not? This was posed to kids. The kids had a day in their classroom to understand the problem, and then they were assigned to work on it over time, and then they came back that Friday, and they had to have a completed test. And we took this project, and we scored it. But we just didn't stop there because everybody was saying, wait a minute, maybe it's not the kids' work. Maybe the kids had resources. So then the following Tuesday, they were given an on-demand task that was that required the same mathematics, slightly different context, and then we measured those two. And that was how they got these richer problems. So there's sort of a learning task married with a on-demand test. I don't know if this actually was put in the content specifications, this exact task, so I'm not making this up. This was in the Smarter Balance document. How they plan to pull this off, I have no idea. Will they actually have learning tests? They might not, but this was something that was done, and I just wanted to share with you that particular work. So, and these were the other ones from that same project. We did one about a goat. We did one about this. We did one about opening an internet business. So there was several of these that we did. So let's go back to the 4 claims, because this is really the punchline for what do we need to prepare our kids for if they're going to be ready for the Smarter Balance test as defined by this. So let's go back to those 4 claims. The first one, students can explain and apply mathematical concepts and carry out mathematical procedures with precision and fluency. That is going to be measured mostly with short tasks. The items will account for 40% of the student's score, and almost all of these will be done on a computer, and probably the computer in May, the large majority of them. Second one, students can frame and solve a range of complex problems in pure and applied math. That will be measured with these apprentice tasks or these expert tasks. And that task will have to be human scored, and it's going to make about 20% of the total score. How about the next claim? Students can clearly and precisely construct viable arguments to support their own reasoning and to critique the reasoning of others. Once again, that's going to be measured with a scaffolded or unscaffolded task. It's got to be machine scored, and the total will, once again, it'll account for 20% of the total score. So right now, just to keep score, half of the test is going to be multiple choice at this point. Half of the test is going to be performance assessment. How about the last claim? Students can analyze complex real-world scenarios and can use mathematical models to interpret and solve problems. Once again, this is going to account for 20% of the last 20% of the score. It's going to be, it can only be measured using these performance tasks that have to be human scored. So if you're a student in California, you're going from a test that was all multiple choice to one that's now only 40% multiple choice, 60% performance assessment. That is the current state of what the design is. Will that change? Probably. Will it change significantly? I don't think so. But there's other factors that will go into figuring all that out. So this is I think a really significant shift. And when you look at the content specification document and you look at the appendix, the types of problems that are shown are these MARS assessments. And so figuring out ways that we can get kids to be doing performance tasks in rich ways would probably be good preparation. We can't say, well, we'll just keep doing what we're doing because we're being measured this way with the state, and then think that we can flip on a switch and all of a sudden kids are going to be able to think, explain, show their work, and perform. So I think we have to think about, and at the same time, it would make no sense to just throw out everything we did tomorrow and try to do something different overnight. We get all sorts of pushback. So you need to be strategic about how we are going to move our teachers as well as our students as well as our parents into being understanding that there is being a dramatic paradigm shift towards higher level thinking skills as we move forward. And this is the proposed timeline. We will be seeing examples in 2013 of some of these instruments coming out, and there'll be requests to do field testing if you're so inclined. You might want to look at maybe field testing some of these items as they become available and things along those lines. And then, of course, the year 2014-15, the CST test will no longer be administered. In its place will be this Smarter Balance test. Time. We can absolutely take a break, and I will stop talking, and you guys can start talking.
Questions from all of you, and then I thought we could spend a few minutes talking about what a consortium might look like and how we would proceed to think about bringing David to Alameda County on, in a more official capacity. So, David, come up and
Sure.
I've heard a whole number of actual questions. I did want to say this before we go to questions. As superintendent, it's been a while since I've sat through 2 lectures on math and loved them. So let's give him a round of applause for that.
I have a lot more problems that you could do. No, aren't you? Yes. And where you're from when you...
Have you had thoughts about the transition, and knowing that several years down the road, I mean, the elementary transition is going to matter for us high schools equally.
Yeah.
It's going to have equal impact, if not more. How do we transition without kind of fumbling over ourselves trying to come up with the next thing to get prepared?
Yeah. So I have. So we're working in New York and Chicago and a number of districts around here, and we're doing 2 things. And it's not just at the high school level, but actually I have more resources at the high school level than anywhere else. But basically what we do is that we really believe that these apprentice tasks that we have are excellent instruments for formative assessment. So we don't need to be testing kids any more than we need to. But we do need to get kids, and first of all, we need to get teachers. Everybody in the world says, hey, we use professional learning communities. We are data driven. We do formative assessment. But assessment isn't formative unless you actually do something with that data and actually teach, change what you were going to do next in the classroom. So one of the things that we have promoted a lot is to use these performance assessments and have teachers that are teaching like all Algebra 1, when they come to simultaneous equations, decide, hey, this is a nice task on simultaneous equations. Let's all come together. Let's all give this in our classrooms. Come together, look at student work, and then revise our teaching and lesson. And if we do those in cycles, it'll start to get It'll start to get teachers aware of how their kids will be performing on these kinds of tests, what they need to do for instruction, and it will improve instruction. The other thing that we have that we're working on with Alan Schoenfeld from Berkeley and the Shell Center in Nottingham, England, is the Gates Foundation has funded a project. Let me just show you what these are. And these are going to be public domain. So let me just share with you really quickly. So they're teaming. So these are the two authors of that content document that I just talked to you about. And this is funded by Bill and Melinda Gates. They went to these guys and said, can you design for us some curriculum small curriculum that would be available, that we could try out in our classrooms and be able to learn to be able to do. So they've come up with what they call formative assessment lessons, which actually last for about 2 days. So it's just about the right amount to get a teacher to try something new and to start to not only understand how the curriculum might be different, but also how some of the pedagogy might be. So this is one on sorting equations and identities, and it always starts with one of these apprentice tasks, and you give this to your students, and they come back, and then the 2-day lesson after you've analyzed the data, and they have all these tools to help teachers learn to analyze data well, like these are the different issues that came up, and these would be suggested questions, prompts, things that teachers would need and be able to use to address those. And then there would be this activity, and the big activity here is this equation always true, sometimes true, never true, and then get kids to start to think about it, create models, things. They can use area models, they can do it lots of different ways, but it's a whole card sorting activity. So these kids actually get these cards, they're sorted out, and they have to classify them. Always true, sometimes true, never true. And so that they really go in depth. And these are what we call formative assessment lessons. So this wouldn't be the first time they ever saw equations or anything like this, but it was a way to solidify these. These cover all the high school standards and everything from grade 6. Eventually they'll be from 6 up, and there'll be at least 20 at each grade level unit. Our strategy is to try to help teachers sort of ease into this work and use these materials. And Neil, these are the things we're trying out in Berkeley classrooms with lots of success. So they go anywhere from these were we wanted the Gates to fund a lot of this, but they actually gave us 6 through Algebra 2. Although I think in the end there will be a few for Algebra 2, but full range for 6 through geometry.
I know where these are housed on the website, on the web, and so we will get the link out to all of you. Right now, they just have the high school lessons posted, but they are working on middle school ones. So we'll get you the information of where you can look at these.
I have it on the slide. I'll put it up. But anyway, what I want to be cautious about, if we just, because we're asking teachers to think about doing it, this takes a little bit of PD. It's not just, if you just hand it to teachers, well, we know that, right? It won't be any, curriculum isn't magic fairy dust. We want good curriculum to help teachers ease into that. But this would be these kinds of things to have. So what we don't want to say to teachers is, draw out your textbook tomorrow, here you go, do all this. It's just not going to happen, right? But I think that there are really proactive things that we can do around formative assessments and a formative assessment cycle and giving teachers curricular materials that will really help them do that. We've actually designed some of these for our K through 2 materials. In fact, New York City commissioned us to write a formative assessment lesson model for every grade level from kindergarten all the way up through. And so we sent that off to New York City and, after we piloted in this area. So there'll be some curricular materials that could be available that teachers could sort of start to move in this direction. Yes. Yeah, that's. I think that's a really good aspect. In that project that I was saying that we were also funded, a different one by Gates, will include actually some of these, and also this whole idea that we assign exercises for kids to go home and do homework, and some kids do it, lots of kids don't. People find that the homework is in many cases isn't really helpful. It becomes sort of busy work, all that kind of stuff. And this whole idea that if you really start to think about the math, unfortunately, mathematics too often is taught, the high level stuff is taught the same way that skills are taught and vice versa. Whereas the way that you teach skills or procedures is a different kind of instructional strategy than how you would teach problem solving or proof, argumentation, connection, and stuff like that. A lot of the work that we're infusing in our program is skill development and applying and using procedures will be part of a gaming environment. So I don't know what the whole world is doing, but I think it does have legs. It does have a lot of interest, and I know that our program will have this gaming aspect to it. I think a little bit of both, actually. We're going to make use of lots of video, short clips and stuff like that, and then in the gaming environment, it's going to feel like a game, like you do on the computer and play. Well, so we were doing things around at the very early grades about looking at acquisition of skills around your times tables and things like that, and then earning coins and all those little things, these accomplishment coins. What we wanted to do is focus more on the notion of accomplishment, versus necessarily all this extrinsic ideas. But a lot of that is being worked out right now. I'm personally not an expertise in gaming, but we are bringing the gaming community in to help design this kind of stuff. So I think we will see down the line the use of this, and I know that a number of experts like Devlin and others from Stanford have written pretty compelling papers about that idea of using gaming as one of the strategies we want to be able to do. Yeah, if you have a grand designer or something like that who is very interested in that, feel free to contact me. I'll put my email information up here on the board. But if somebody is interested in pursuing that, yes, there is. Other yes. Right. Running computer-generated scoring, and we're going to move 60% of that work to multiple aligned professionals. So yeah. There's a lot of work that's put into it. It is, and it's so foreign to Americans. The rest of the world scores their high-stakes exams this way, but here it is a big paradigm shift, and there's fears around reliability coming out of that. There's also a notion of cost. That how in the world are we going to be able to afford this? So I know that I was in a discussion. So I was in a discussion. This was with Park, not Smarter Balance, but I was in a discussion with the 23 districts from Park last fall in Washington D.C. And one of the first questions came up, and I don't want to get too far away. I tried to circle back, but one of the big questions came up was how can we afford this? How can we afford this? This is going to be so much more expensive. But what they actually looked at was they had done an analysis of how much it cost each of the states to do their current No Child Left Behind test, and they had this wide range. So it pure per pupil cost, and it was quite wide. But with Maryland being the most expensive, and I forgot who they had, and it was California California was probably at the bottom, but we weren't part of Park at that time, so we were spared being the most inexpensive test. But anyway, they looked at the median. They felt, and then they did their projectors, and they said that the Park test was going to cost something right sitting at the median of all of those, and that was understanding that these tests were going to be scored. Getting back to scoring and the human resource element of this. So this is just David talking off the top of his head, and nothing. And the thing that keeps me up most at night when I start to think about this work is how are we going to score these? So there's some wonderful models of how to score it, including the work that we've been doing in the Silicon Valley since 1998. And that is that it wouldn't cost, the cost would be minimal if instead of requiring teachers to teach 180 days, we had teachers teach 179 days, but we owned that last day. And that last day, everybody in the state or everybody in the country either scored the writing test or the math test. And it could all be done on that one day. It would be the best professional development that ever occurred, and we could really leverage that. That's my dream. Now, lots of things would have to be in place for security and stuff like that, and it's not like that isn't fraught with some challenges. But if everybody in the country knew that they were scoring on that day and that their scoring was going to be audited, I think we would have a really powerful system to move teaching and learning forward. So that doesn't actually answer your question, but I think this idea of the other thing that, and I'm not, maybe I don't understand your question completely, but the other thing is how do we communicate the results from rich assessments versus just giving scores? Everybody's pretty satisfied with a score or a little bar graph that says you're here or you're here in your ranking versus really giving back feedback that tells kids what they know and able to do. One of the things that I'm pretty proud of that we do with the data from this MARS test is that we create individual student reports that aren't about numbers but are about a descriptive analysis of what kids can or are able to do. Everybody needs to know what kids can or are able to do, and where they're struggling, what they need to work on more, and stuff along those lines. That kind of data, to me, that's being data-driven, as opposed to it's real easy to produce all sorts of numbers that are pretty opaque. Yeah, and I probably have very little expertise in going exactly where you.
I'm thinking that it's good perspective to do for right now, because we're talking next that our fifth graders are going to be in eighth grade with these kinds of things. I think that this resource needs to be out to their perspective how they support the work of assessment and interactive work.
Yeah, I'm with you completely, and this idea that that the kids that are in fifth grade now will be in eighth grade when they do it, or the kids that are going to are taking the CST in third grade this spring, will be in middle school. And if in the next 3 years these students are just being taught in the way that they have been for the first 3 or 4 years of their career, they're not going to be prepared. And to think that somehow miraculously we can turn on the lights once they get to middle school is just it's just incredibly naive. And so the way that you frame that is right on. I think it's the perfect way to be looking at it.
Great. I think